Okay, guys, so let's define what is a force, right? This video. So a force can be defined as simple words as a push or a pull. And it can also be defined as a quantity that causes change. So it changes the state of rest or the state of motion of an object. So an important thing about a force is that it is a vector quantity. Which means that it has a direction, and when, let's say, two forces are acting on an object, you have to add the two or more forces as vectors. So let's say there's a force F1 acting on an object, right? And then there's a force F2 acting. So let's say this dot is that object, and there's a force F2 acting on the object. So the net force is going to be the sum of these two forces, and that is going to be a force that, so the net force is going to be somewhere in this direction. And so the object is going to move in the direction of the net force in this case. So let's say that this is that object, right? And if I apply a force, two forces, so this is like F2 and this is like F1, and we know from intuition that this box is going to move in along the diagonal, right? It's not moving this way. It's not moving this way. It's going to move along the diagonal. And so that's that's an important point. And when we solve problems, we always have to make sure that we find components of the force if it's at an angle and so on. And we'll talk about that more when we do examples. So let's look at some examples of forces. Right. So the most common example that we all know about is gravity. Right? So gravity is a force, is the force of attraction that the planet applies on any object in proximity, right? So you don't need to be in contact with the planet. It's a non-contact force. Gravity is a non-contact force. So that means that forces can be non-contact or contact forces. So if you throw an object in air, or if like a satellite in space, it does not have to be in contact with the planet to experience the force of gravity. So an important thing about gravity is it's always towards the center, towards the planet, right? Towards its center. So let's say if this is the surface of the planet, and let's say like there's an object that you throw like that. Gravity is always going to be straight down towards the center of the planet, right? And a typical, like, for projectiles that we throw, we can assume that it's for our purpose, it's let's say a flat surface. Gravity is always going to be straight down. Okay, so this is F. The typical symbol for gravity is like Fg and W, right? So this is Fg is going to be all straight down, so it's vertically down. And so I'm going to be using both symbols. So I like W because because it's more common, but F sub G, but W is also used for work. It's almost impossible to avoid overlap of notation in physics text. So I'm going to be mostly using W, but if I use F sub G, I'll let you know. And another important force is the normal force. Right? Normal force is a contact force. So it's the force on two objects in contact with each other. So this pen is on this surface, right? So it experiences a normal force which is perpendicular to the surface. So if you place an object on a surface, the normal force is perpendicular to that surface. And the important thing is that if you tilt the surface, normal force goes along that. So the normal force on this object is going to be tilted also. It's always perpendicular, always makes a 90-degree angle. So that's an important thing to remember. And a misconception about the normal force is that it's always equal to W, like the weight. So there's a weight acting on this object, right? So in this case, normal force is equal to W, but that's not the case. The weight is always straight down. So in this case, you have to resolve the components, and we will talk about that more when we do examples. So that was just a comment about misconception. It's not always equal to W. Okay. Another force is the force of tension. Right? So tension is a force that is triggered in a string as a result of a pull. So if you, let's say, have a string like this, right? So if I'm pulling on the string towards the right, I feel that the string is applying a force on my thumb or my hand towards the left, right? So it's that force that let's say this is my hand, and I'm pulling the string, and I'm pulling the string in this direction. So the force on the string is the force that the string applies on me is towards the left. Right? So that's the force of tension. The typical symbol for this is a T and also F sub T. And so let's talk about another force. Again, we'll talk more about these when we work on examples. Another force is the force of friction. So friction can be two types. Again, it can be static, it can be kinetic friction force. So friction is a resistive force that resists motion or tendency to move. So if an object is trying to move, but like for example, when you're moving out, you're pushing a piece of furniture, right? Heavy furniture. It does not move instantly. Like it's not moving, but there is a resistive force that you feel on yourself. So that's when we say that a static force, a frictional force, is acting on you. When an object is moving, you still feel some resistance. So that's kinetic friction. Again, we'll talk about that. So if you so it's always opposite to the direction of motion. So if this object is moving in this direction, there is I'm just drawing the forces that are relevant. There's going to be a kinetic frictional force in the opposite direction, and so it's always opposite to the direction of motion. And so another force is the spring force. So a spring force is typically represented as F sub S, but again, so you see the overlap. So this is so let's write F sub SP for spring. So it's the force that a spring applies on an object. So if you are if an object is being pulled, so if you extend an object attached to a spring, there's a force that the spring applies in the opposite direction. So if I let this go, it's going to oscillate like this, right? So when it's a compression, it's the spring force is in this direction. If it's an extension, it's in this direction. So that's the spring force. If there's an extension, the spring force is going to be in this direction. And then when there's a compression, the spring force. It's a restoring force. It's always towards the equilibrium. Again, we'll talk about this more later. The last force that I want to talk about is the drag force. So drag force is also, you can say, resistance, but it's resistance in a fluid. So if you have, let's say, a basketball, you throw a basketball, let's say it's moving in this direction, right? The force, the drag force, is going to be in this direction, typically represented by capital D or F sub D, and then there's, let's say, a weight, force of weight, gravity also on it. So it's always opposite to the direction of motion, and an important thing about the drag force is that it's typically velocity dependent. Again, we'll talk about this more in coming videos. Okay, so these were the forces I wanted to talk about. We'll talk more about forces and define Newton's second law in the coming video.